Year 1915. Albert Einstein proposed his theory of general relativity, which changed our understanding of universe completely. Year 1969. Humans first landed on Moon. Year 1998. Humans established their first award in space, that is International Space Station. These are among the greatest achievement of humanity. However, अभी जो नासा और अदर एजेंसी मिलकर करने जा रही हैं वो शायद इन अचीवमेंट्स की वैल्यू को कम कर दे. On December 28, 2021, NASA and European Space Agency and Canadian Space Agency एक बहुत ही एम्बिशियस मिशन लॉन्च करने जा रही हैं जिसका नाम है जेम्स वेब स्पेस टेलीस्कोप. ये आने वाले दशकों में, आने वाले डिकेड्स में हमारे लिए प्रीमियर ऑब्जर्वेटरी का काम करेगा यूनिवर्स को ऑब्जर्व करने में. एंड इट विल स्टडी एवरी फेज ऑफ हिस्ट्री ऑफ आवर यूनिवर्स. वी ऑल नो दैट आवर यूनिवर्स स्टार्टेड सम 13.8 billion years ago. So this telescope will help us to reach further back into time and help understand the primitive stage of universe in more and more detail. So in this lecture we will see what is this telescope, how it will work, what are its functions, what are some of the basic cosmological principles on which modern astronomy is based, and how it is different from the Hubble Space Telescope. Taking one by one, the James Telescope is a large infrared telescope, which means it will work in the infrared range of electromagnetic wave spectrum. उसमें ये इंफ्रारेड रेंज पे काम करेगी, उसकी रेज को ये डिटेक्ट करेगी. इसका जो डिजिटल डिटेक्टर जो यहाँ लगा रहेगा आफ्टर प्राइमरी एंड सेकेंडरी मिरर के बाद. This telescope has 6.5 meter diameter प्राइमरी मिरर. इसकी डायमीटर कितनी है? 6.5 मीटर है, जो कि हबल से काफ़ी बड़ी है. हम आगे देखेंगे कंपैरिजन. और ये किस रेंज में काम करेगा इसका डिजिटल डिटेक्टर? इंफ्रारेड रेंज में. The telescope will be launched through the Ariane 5 rocket. ESA यूरोपियन स्पेस एजेंसी का वन ऑफ द मोस्ट पावरफुल रॉकेट्स इन द वर्ल्ड सो फार. उससे इसको लॉन्च किया जाएगा ऑन 18 December. As I have said earlier, this will be our premier observatory for the next coming decades. So this will help us to understand or observe every phase in the history of universe. Here the universe started some 13.8 billion years ago, 13.77 more accurately. So, and it expanded both in time and in space. The universe after explosion, the Big Bang explosion, expanded both in time and space. So the James Webb Space Telescope, suppose placed here, will help us to look further back into time and reach further away in the space. And as we know, light takes some time to travel. As we look further in the space, we look further back in time, simply because we are looking at the things that were in their past. Because light is reaching here on Earth or to the James Webb after traveling billions of light years. So the thing which we are observing is as if it were in the past. So as the further we look in the space universe, the further back we will see in the time. I will enumerate this principle in more detail later in the video. This is one of the basic principles of astronomy. So this will help us to look at the phenomenon of Big Bang, which happened almost 13.7 billion years ago. Then there was dark ages, then there was formation of galaxies, then there was formation of stars, then there was formation of planet, then there was somewhere around 4.5 billion years ago our earth formed, and then there was formation of life, invention, or you can say development of life on these complex planetary worlds. Before going forward in the details of cosmological principles and its function, let's see who is the collaborator of this uh, telescope. So the European Space Agency, Canadian Space Agency, and NASA are the three main project collaborator. Then NASA has a center in Goddard Space Flight Center. This will manage the development effort up to the launch of the telescope. Then further, after launch, the main institute is Space Telescope Science Institute, which will manage the telescope, or you can say operate the telescope after its launch and establishment in the orbit. Unlike Hubble Space Telescope, the James Webb Space Telescope is going to be placed in solar orbit. Hubble Space Telescope was in the Earth's orbit. Further, since we are placing the James Webb Space Telescope in the solar orbit, so it will not be possible for us to repair or give it service via space shuttle. So there were development of many technology to achieve this objective without needing the support of human in the space. We have to launch, unfold this telescope, and place in the orbit. So these are some of the most innovative technology so far achieved by the humans. So this lens can fold, one of the most innovative technology, since the Ariane spacecraft cannot get this telescope inside its, because the diameter is less than its mirror's diameter. So this mirror is foldable into 18 parts. So first of all, the whole telescope is a foldable telescope which has to be unfolded in space by itself through relay mechanism and other things. So this is one of the most challenging technological problem for the NASA scientists. This will be folded into a very small area and placed into the rocket. And the mirror is made of ultra lightweight substance called beryllium. Beryllium is a ultra lightweight substance which has been used to make this mirror. Further, since the telescope is in the solar orbit, and we know that the a constant bombarding of solar sun rays on the telescope may damage its instruments. So we have to protect it by a shield. The sun shield is a 5-layer sun shield made of Teflon type of material, and this will attenuate heat and sun rays from the sun and reflected rays from the earth and the moon a million times. So to save the instrument in space, to save it from the heat of sun and to block the rays of sun and earth, we have to protect it by a shield so that it can observe the universe safely without interfering with the rays of sun and earth, reflected rays from earth and moon. Since the telescope is further in space, 1.5 million kilometers in the space, you can't touch it by hand. No humans have ventured so far away in the space, and we haven't developed a technology to venture so far in the space. That's why we need to achieve all these things by automation, by some pulley and gear mechanism and relay mechanisms. So as I have said earlier, the telescope will orbit the sun, not the earth. So here is the orbit of the Hubble Space Telescope. Here is the moon, something about 3,84,000 kilometers away, and here is the James Webb Telescope about 15 lakh kilometers away, or 1.5 million kilometers away, in the orbiting the sun along with the earth. So the James Webb Telescope will be placed at a point called Lagrange point 2. So what is this? This is one of the solution to place three bodies, sun, earth, and the observatory in a stable orbit without uh, affecting its orbit for a long time. Stable orbit, you know that gravity is a attractive force. There are some solution that how we can place three bodies in orbit to each other so that none of them fall into or crash into another one. So this is one of the solution. The first is L1 here, second L2, then L3, L4, L5. One mathematician gave this solution in 18th or I think 19th century, and since then we are using his name as Lagrange. So the observatory is placed here in this orbit, orbiting the sun, not the earth. Unlike moon which is orbiting the earth, the observatory will orbit the sun along with the earth. Furthermore, what is interesting about this point is, suppose you have erected your shield here, then this, since the observatory will remain in line with sun and earth forever, so you need only one shield to block the light and heat coming both from sun, earth and moon. So सन, अर्थ और मून से आने वाली जितनी भी रेडिएशन है, क्योंकि ये उसी की एक ही लाइन में रहेगी, हमेशा अर्थ के साथ ऐसे मूव करती रहेगी सन के चारों तरफ, तो एक ही शील्ड काफ़ी है इन तीनों बॉडीज़ की। जो लाइट है, जो पॉल्यूटिंग लाइट है, इसके लिए पॉल्यूटिंग इन द सेंस कि इसे हीट भी करेगी, और सेकेंडली जैसे जो अदर बॉडीज़ हैं यूनिवर्स में, उनकी लाइट को इस तक क्राउड आउट कर देगी या इस तक नहीं पहुंचने देगी। तो इनको हम पहले एक ही शील्ड से ब्लॉक कर सकते हैं। इस ऑर्बिट का एक और फायदा है। देन कम्युनिकेटिंग विद द वेव। अब आप, एज आई हैव सेड कि दिस इज द अर्थ एंड इट विल रिमेन इन लाइन विद द अर्थ फॉर एवर। सो द मिडनाइट पोर्शन ऑफ द अर्थ, इट विल बी ओवरराइड ऑफ द मिडनाइट पोर्शन ऑफ द अर्थ। जिस अर्थ के जिस भी पार्ट में मिडनाइट रहेगी, उसके ओवरऑड रहेगा। तो आपने मान लो 3 टेलीस्कोप लगा रखी हैं अबाउट 60 एंगल पे या 120 एंगल पे अर्थ के सेंटर से, तो कोई ना कोई टेलीस्कोप या कोई ना कोई जो एंटीना है वो इसको कैच कर सकता है। सो वी हैव 3 डीप स्पेस नेटवर्क located in Australia, Spain and California, USA. So these are at about 120 degree to remain in touch with the telescope, to remain in touch and in communication with the telescope. So further, how long will it take to wave to get to L2? कितने दिन लगेंगे वेव को? सो करीब ये अर्थ से लॉन्च होगी और ये करीब 3 दिन में जो मून की ऑर्बिट है उसे क्रॉस कर जाएगी, जो कि करीब 1/4 ऑफ द इसका जो टोटल पाथ है उसकी लेंथ को ये सिर्फ 3 दिन में कर जाएगी। लेकिन और ये L2 पॉइंट तक पहुंचने में लेकिन इसे 9 दिन में, ये 9-10 दिन में ये अपनी मैक्सिमम जर्नी कर चुकी होगी, ये वहां तक पहुंची हुई है। लेकिन L2 में प्लेस करने वाला मैकेनिज्म और इसे अनफर्ल करके इसे ऑपरेट करने वाला मैकेनिज्म काफ़ी कॉम्प्लिकेटेड है। तो ऑपरेट लॉन्च से लेके 18 दिसंबर से लेके करीब इसे 30 डेज लगेंगे अपने कंप्लीट ऑपरेशन में आने के लिए। एज आई हैव सेड अर्लियर, हबल स्पेस टेलीस्कोप वाज अवर and is our premier space telescope so far. However, there is some basic differences between Hubble and James Webb. One of them is the range in which these are observing universe. Hubble Space Telescope was observing universe in the ultraviolet and visual range mostly, and there were also some infrared sensors. So these are the two images of Hubble. One is of infrared and one is of visual range. So as you can see, we can see we can have much more information in IR bracket infrared range than in visible range. As you can compare these two images, this image is much more detailed than this one. So this is the main reason why we are launching the James Webb Space Telescope in the infrared range. So main जो काम का रेंज रहेगी जेम्स वेब की वो इंफ्रारेड रहेगी. Further, people are saying that James Webb Space Telescope or simply Webb Space Telescope is going to be a replacement of Hubble Space Telescope. But scientists say that, or even NASA is saying that it is not a replacement. It is not a replacement, but it's a successor because these are having completely different abilities, and Hubble has done its own research in the visual range, while Wave will done its research in IR range. So these are not replacement but a successor. Further, Hubble's result have motivated scientists to launch such a telescope. हबल ने जो देखा है अब हम उसके बियॉन्ड देखना चाहते हैं, इसलिए हम IR में इसे लॉन्च कर रहे हैं, ना कि विजुअल या अल्ट्रावायलेट में. As you know, since the universe is expanding due to dark energy, this is one of the other cosmological or astronomical principle which I am elaborating. Please pay attention. As you know, since the universe is expanding um, very fast, the farther away you are from an object in the universe, I'm not talking about some other star in our own galaxy or even cluster of our own galaxy. So let's say this is a galaxy some 2 billion light years away. So the further away you are in the space from any object, the further the speed with which you are going away is also greater. This is known as Hubble's law. Your velocity of separation is directly proportional to your distance from that object. Suppose this is our solar system and this is a galaxy sitting some 2 billion light years away. Then this is going with some 100 million kilometer per hour. Let's say this is going away some 100 million kilometer per hour. Then there is one more galaxy sitting some 4 billion light years away. Then this is going away with a speed of let's say 200 million kilometers per hour. So the further you are from an object in the universe, the further with higher velocity you are going away from that object. So what happens with that? The light emitted by that substance gets shifted into the higher wavelength lights, or what we call red shift. Suppose this the light emitted by this is ultraviolet or violet light or blue light, then this turns out to be due to extension of wavelength, this turn out to be, as we observe this, will be become red light or even infrared light. So most of the data of the universe, the further the objects are is available in the red or infrared spectrum. That's why we are launching the James Webb Space Telescope to observe these two radiation bands and to observe the universe in the farthest reaches. Thus, observation of these distant objects like the formation of first galaxies, requires an infrared telescope. Since you know the universe is 13.8 billion years old and the first galaxy formed some 2 billion years after the birth of the universe. So we need at least look back to 11.8 billion years back into the time. And since these are much further away in the space, we need infrared technology to observe them because their maximum light is available in the infrared range. This is the other reason that Webb is not replacement of Hubble. Webb is not a replacement of Hubble. In fact, it has quite a different area of work, which is IR, infrared. So, suppose this is a star in a distant galaxy and the galaxy is moving away from us. So, what happened? This light, which was like this, will stretch into like this, like Doppler effect. So As you know, suppose this was of ultraviolet frequency or wavelength, but this now has become some of higher order wavelength, which will be infrared or red or even meter waves. So most of the our observable universe emits light in the ultraviolet band, but as they reaches the earth, they become infrared or red or infrared. So further, if something is moving towards Earth, then there will be a blue shift. If the light is observed in say red or yellow spectrum, then this will move to higher, since this light will get compressed. Since this light will get compressed because you are moving towards that object or that object is moving towards you. So this is simple Doppler effect in the light. Doppler effect is used for the Doppler effect is used for sound waves, but the same thing is in astronomy is called red shift. Since most of the universe is going away from us, we observe red shift, not blue shift. So here the Doppler effect is illustrated. Suppose the light is emitted in this band, and if you are if you are moving towards the object, then you will observe that the light had shifted towards blue. Further, if the if the object is moving away from you, then you will observe that the radiation or electromagnetic radiation has shifted toward the yellow or red. So this is why we call it red shift. This has been enumerated in 1930 by famous astronomer Hubble, Edwin Hubble, and he also proposed his law of Hubble, that is, the further away a thing is from you in the universe, this is distance, the higher is the velocity of separation. The velocity with which moving away from us is directly proportional to the distance it is away from us. Further, as we are comparing these two telescopes, James Webb Telescope has much larger primary mirror as compared to the much smaller primary mirror of the Hubble. Further, Hubble was in orbit of the Earth and it was very close to Earth, 570 km, and the James Webb Telescope is 1.5 million kilometer away from the Earth, away at the second Lagrange point. This is another difference between the. As I have said earlier, since Hubble Space Telescope was in the Earth's orbit, we can service it by this space shuttle, very famous NASA shuttle called space shuttle. इससे हम बार बार जाके उसके रिपेयर और वो कर लिया करते थे, लेकिन since James Webb Telescope is in further deep in the space, we can't go there to even set up this or even to service it. So whatever has to be done automatically. Now final, as I have said to you, that as further away you can see in the space, the further back in the time you can see. For example, let me illustrate this. Suppose a galaxy is sitting formed somewhere here in the early ages of the universe, and now you are here at this 13.8 billion line. You are here. A photon emitted there at this time and traveling to the Earth, but universe kept expanding and the light took its own time to reach Earth. After some, let's say 13.6 billion years, it reached Earth. Then what we will see today will not be a galaxy of present time, but be a galaxy that was formed some 13.6 billion years ago. We will see the 13.6 billion years past state of that galaxy, not the present state of the galaxy. So definitely as far away we can see in the space, the far back in the time we can see. So the Hubble Space Telescope was good up to this point in the time, up to let's say 12.8 billion years in the past ago. इतने टाइम तक हबल भी देख सकती थी, इतने बैक। लेकिन जो जेम्स वेब टेलीस्कोप है वो कहाँ तक देख सकती है, वो करीब करीब यूनिवर्स की जो डार्क एजेस थी, वेरी इन्फेंसी ऑफ यूनिवर्स थी, वहां तक देख सकती है। और फिर जो इसकी जो थ्योरीज है, चाहे वो स्टीफन हॉकिंग ने दी हो या फिर अदर जो इवेंट हॉराइजन की जो थ्योरीज है, इवेंट हॉराइजन की, उन्हें टेस्ट करने में हेल्प करेगी कि भाई आप जस्ट आफ्टर द बिग बैंग व्हाट वर द कंडीशंस, और हमारी थ्योरीज क्या प्रिडिक्ट करती हैं, क्या ये कंडीशंस हमारी जो प्रिडिक्शंस हैं उनसे मैच करते हैं तो हमारी थ्योरी ठीक है, अदरवाइज वी हैव टू मेक करेक्शन इन देम। सो दिस इज one of the basic principle of cosmology, and here after the expansion of Big Bang there was a cosmic microwave background which was discovered in 1950. So and the discoverer get Nobel Prize for that. So this is the basically the cosmic background radiation and the leftover of Big Bang explosion. Big Bang explosion होने के बाद जो लेफ्ट ओवर था उसकी जो रेडिएशन थी उन्हें वो माइक्रोवेव में एमिट हुई थी, माइक्रोवेव रेंज में, और वो आज तक यूनिवर्स की चारों डायरेक्शन से, सारी डायरेक्शन से वो एनर्जी हमारे पास पहुंच रही है, और उसे हम क्या बोलते हैं, माइक्रोवेव कॉस्मिक बैकग्राउंड रेडिएशन। तो इसमें ये जो मैप है ये मैप है यूनिवर्स का माइक्रोवेव कॉस्मिक बैकग्राउंड रेडिएशन का, MCBR। दिस इज वन ऑफ द मोस्ट फेमस मैप इन द एस्ट्रोनॉमी, और इसने पूरे एस्ट्रोनॉमी की डायरेक्शन को चेंज कर दिया था। फर्दर मैं आपको एक चीज और बताना चाहता हूँ कि जो हमको पता है कि यूनिवर्स 13.8 बिलियन ईयर्स की इसकी टाइम की डायमेंशंस है, लेकिन व्हाट अबाउट इट्स स्पेस डायमेंशन, ऑब्जर्वेबल यूनिवर्स की स्पेस कितना एक्सपेंड हो चुकी है अभी तक। तो इसकी डायमीटर है, ये जो यहाँ दिखा रखा है स्पेरिकल थिंग, इसकी डायमीटर अर्थ के पॉइंट ऑफ व्यू से ये ऑब्जर्वेबल है। यूनिवर्स कैन बी फाइनाइट इनफाइनाइट, नो वन नोज, पर एज फार एज वी नोज, व्हाट एवर वी नोज इज अबाउट 92 बिलियन लाइट ईयर्स। सो लाइट जितना 92 बिलियन ईयर्स में चल सकती है उतनी ऑब्जर्वेबल यूनिवर्स की लिमिट्स हैं जो अभी तक हम देख पाए हैं। यूनिवर्स कैन बी बिगर देन दिस, और यूनिवर्स कैन बी इनफाइनाइट, नो वन नोज फॉर श्योर। सो थैंक्स फ्रेंड्स, if you want to get some more videos like this, और आप अपनी नॉलेज के होराइजन को वाइड करना चाहते हैं, उसे डेप्थ देना चाहते हैं, तो प्लीज़ हमारे साथ बने रहिए, हमारे वीडियोस को शेयर करिए और लाइक कीजिए। थैंक्स।